The concept of this video is on function notation. So the first thing I want to look at is this. This is exactly what a function would look like, but its pieces can confuse students. So I'm going to go through each piece and kind of identify what the meaning of each piece is. So this part right here is the name of the function. This function could be named f. You might also see g, k, s, etc. It's just, we would call this f of x, okay? That's how we'd say that, f of x. And again, this f is just the name. The second part of the function, this part right here, oops, sorry. The second part of this function right here is the input or whatever is what we would call that, okay, the input. And the input is what we plug into x in the function or in the equation. Maybe it might be a better way to think about that, in the equation. Okay, so whatever you see here, you're going to end up plugging that into this x right here, okay, to actually get the output, all right? The next part that is identified is this part right here, right? This is the next thing that's identified if we go around the circle, and that is known as the actual function, okay? This is actually what is happening if we think about this as a machine. This is kind of the work that's being done. So this is the function that you'd actually, sorry about the bell, the function that you'd actually plug into. And last but not least, the entire side of this over here, so this entire thing right here all together, while its pieces at the beginning represent the name of the function and the input, it also, if you see a number there, this also represents the output, okay, or the answer after you substitute. Okay, so now think about it like a function machine, right? So your input is your x value. Your function is the equation. So if I wrote this in, this would be like 3x plus 4, right? And my inputs would be x's, and my outputs would be the f of x, right? Or the answers. That's what's coming out of the machine, okay? So the x is what we put in, the function's what's happening in the middle, and the output's what we get. All right, so we can see this in multiple ways, right? So like if I gave you just a very basic example, like the function is g of x equals x plus 1, we can see this present itself in two ways, right? I could ask you, or I could ask two things. I could say, hey, what's g of 1, question mark, and then I could also say g of x equals 5. So there's two different things that could happen here. When I say, what is g of 1, this says, what is the output when the input is 1, right? So what that means is I'm going to plug 1 into x, so this would be g of 1 equals 1 plus 1, so g of 1 is equal to 2, right? So the input in this case was 1, and the output was 2. Okay, that's how that works. So again, when it's inside, it's what we're plugging into x. When the 5 is outside, right, saying this, it would say, well, what is the input when the output is 5? That's the question, right? Well, think about it with this machine. If this is 5, and I know this equation that happened right here is x plus 1, right? So if my output was 5, what happened or what was put into the machine? That's the question, right? So essentially, 5 is the output, and I don't know what the input is. I could just solve the equation. So I could subtract 1 and get 4 equals x, right? So my input is 4 in this case. My input is 4, and my output is 5. So on this one, in both of these cases, as you finish this, you've got two inputs here, Got two inputs. But when you go to the back, you have inputs here, but be careful because these are your outputs. So I want you to try to figure out what is the input. So this is where you have to go backwards. You're going backwards there, okay? So try this out, and then remember to let me know if you have any questions.